Like in the first image, you can see the face recognition algorithm. If the vehicle is moving in the street and it can detect automatically whether this is that person. If you will save certain images, then it can be able to detect. Algorithms are available for the body joints movement detection, car detection, vehicle parts detection, a lot of things which we can do with these deep learning algorithms and computer vision. Okay, fine, we can move to the next. When we will go into the deep of this deep learning and computer vision algorithms, there is an operation called convolution. So most of the computer vision problems has been solved using this convolution neural network, in which the basic operation is convolution. Basic operation is convolution, which is a pointwise multiplication of two matrices. Every image is a kind of matrices. For example, in every pixel there is a certain value which is stored in a matrix form, and when we have to detect some part or some vehicle, some car, cat or dog, so we have to apply this and in every layer of convolution network, some feature will be extracted and then will be matched automatically for detecting those kind of. Okay, so this is a convolution network for a text, for example digit recognition. So think about an application where we have to detect the road symbols in self-driving car. So in that case, for example, if you have to detect 0 to 9 digit, so this is a solution where multiple layer of convolution is available, and we are giving an input of that image. For example, this is a train network. This is a train network for digit classification. Then the part of that image which we can see, there is an digit 8 which we have to recognize. So for in every part of image, that convolution operation will be applied, and one by one this convolution feature will extract the feature of that digit 8, and at the end of the last layer of convolution, it will pass some feature to the fully connected layer and will be able to recognize those digits. So likewise, if you will, we will give any kind of signal which is available on road, the train network will be able to detect. But for that, you can think, we are detecting only the digits. For that, lot of computation is required. So if we have to detect all the symbols available on road, we have to train lot of network with those symbols, and that will require high computation in our vehicle. Although this CNN is an solution for recognizing and classifying those objects for the self-driving vehicle, we need lot of data, we need lot of computation power, which we have already discussed in the previous slides, right? So this is an example of classification that we can do with the self-driving car. We can go for the next slide. So this is an example for this convolution operation. So think about this first matrix is a kind of image. For image, same kind of matrix is built. If you will see image capturing from our phone, the size of that is 1920 by 1920. So we are taking this image of n cross n. Here we have 5 cross 5 matrix in the form of image, and we are taking convolution filter of 3 by 3. So with the research done in past, they have optimized the size of this convolution filter, and with some algorithms they came up with the ideal filter size with 3 cross 3. Although people are experimenting still with the different size filter, but till now we have optimized value of filter size is 3 cross 3. So if we will apply this convolution operation on this image, just put it on the leftmost top area on that image, this convolution, and then when we will apply this, just pointwise multiply this. For example, when we will apply this, 3 will be multiplied with 1, 1 will be multiplied with 0, 5 will be multiplied with minus 1, 3 next row 3 will be multiplied with 1, 0 will be multiplied with 0, 1 will be multiplied with minus 1, 5 will be multiplied with this, 4 will be multiplied with 0, and 3 will be multiplied with minus 1. So this all multiplication will be added and it will come as 2. So one by one we will slide this matrix filter in the right side, and these 2, 0, minus 1 and 8 will come, and likewise we will slide this in the downwards also, and all this output matrix will come, which is called the feature. So we have extracted this feature which is available on the right side, named by output, with the original image matrix available in the leftmost side using this filter, and the size of output matrix will be n minus f plus 1 multiplied by n minus f plus 1. So you can see the size of original image is reduced after one convolution operation. So this operation will be followed in the next layer, and then same operation will be followed in the next layer, and at the end we will be able to detect the original feature of that image. For example, we have seen in the last slide we have to classify as 8, so we can classify the 8. Fine. So we can move to the next slide. So this is how this networks works. Now coming to the classification model, these models have started from 90 and up to 2017, when we have got mobile net inception. These are the models which have got the maximum accuracy, and now for the classification of car, for the classification of animal, if you will apply this inception or mobile net model, this will give more than 90% accuracy. For some cases it is giving 98, 99% accuracy. So that means these algorithms can be applied for the real-time self-driving car also, for the classification of different objects, which is a most effective feature for the development of this self-driving and autonomous car. Looking at these models, they have got the accuracy with the data available, so that they have planned, different companies have planned to launch their autonomous vehicles in 2020, because up to the 2070 we had these kind of networks which can detect with a good accuracy. And we can go to the next slide. Okay, so this is a kind of classification model called VGG16. In this there are 16 different convolution layer was available with the convolution operation. Then there are some max pool function, and this classification VGG16 have the accuracy more than 95% with the roadside data. So these model can be easily downloaded and can be tested with the different kind of data. From our experience, we have seen the performance of these algorithms. In most cases, the performance was more than 90. Fine. So we can move to the next slide. Then in the beginning, we have seen there are two techniques in the computer vision which are very useful for this self-driving car. One was the classification, other is detection. So in that we have seen with the classification that whether there is a car or bike or some animal, we have to take a bounding boxes near those objects. So when we apply for detection, for example, in the frame we have 5 different classes: bike, car, cycle, dog, and human. Then originally we have to get this Y matrix. Y matrix consists of different thing. There is a PC, which is called probability of an object being present in the bounding box. Then there are BX, BY, the coordinate of that bounding boxes, BH, BW. So basically, when those bounding boxes we have to create, we have to go to the center of that object, and then you have to calculate that BX and BY. Those are the coordinate of that the center of that bounding box, and then if you will be detect the height BH and width W, then we can, with those 4 values, we can create those bounding boxes. So whatever the algorithms available, they use these four values for creating those bounding boxes. And then once the bounding boxes are created, that part will be used for the classification. So inherently we are using classification techniques with those localization, because once those bounding boxes are created, we have to classify whether this is bike, car or cycle, whatever. So out of five classes, these five values are there: C1, C2, C3, C5, C4 and C5. So C1, for example, C1 is the probability of the first class, which is bike. C2 is the probability of car. C3 is the probability of dog. That means in that bounding box, we have calculated the probability of each object, and whichever the probability is highest, we will say this is that object. For example, if the probability of car is high, then we will say inside that background the car is available. If the probability of dog is high, for example C4 is high, then we will say inside that bounding box there is a car, there is a dog. Okay, so this is the matrix we have to get after getting the output in that convolution network for object detection. Okay, we can move to the next slide. So when we will see the networks for the object detection, the basic thing we have to do, we don't do, that network will do, is that finding the bounding box that we have discussed with the highest IOU. Because when we are going to create those bounding box, there will be multiple bounding box will be created, but there is one parameter called IOU, intersection over union. So we have to take that bounding box which has maximum IOU value. So later on we will discuss that what is IOU and all. We have not covered in this lecture. Then we will see, we have to calculate the confidence loss. For example, we have created that bounding box, but we don't know whether there is an object inside that bounding box or not. So we have created multiple bounding box inside that image. Then we will see in which box there is maximum probability. Yeah, there is confidence loss is low. We can see here there are a lot of bounding box created. That that confidence loss will be created, calculated, and once all those things will be done, only bounding box rest in is inside those objects. So once those confidence loss is created, we will see the classification. Confidence loss is calculated, then we will calculate whether which object is there, whether it is dog, cat or cycle. Then using those loss and confidence value, we will be able to detect. For example, when we will see in the next slide, go to the next slides now. Okay, so here we can see a lot of bounding box is created. We are giving input image. There are a lot of bounding boxes created in the second image. Then the bounding box with the minimum confidence loss is highlighted. You can see around the dog and around the cycle in second image, they are highlighted. That means we have got the bounding box with minimum confidence loss. Okay, so after that, the next step is we have to classify whether it is cycle, whether it is dog, whether it is bus or not. So after that, what we have seen in the classification thing, those classification algorithm will be applied for classifying. So you can see in the third image, these bounding boxes are there, and above that there is a written dog, there is a written car, there is a written cycle. So this in the last step, those classification algorithm will work for the classification of the object inside that bounding box. Fine. And for the learning algorithm, these equation will be used. So we can go for the next. I think there is something or not. Okay. So these algorithms we have seen there is a lot of capability in self-driving car, or there are a lot of application we have seen in the field of precision agriculture and all. Likewise, we have got a project for counting the people inside a bus. So that was the project coming from the USA. So there is some company who want to uh, count their crowd inside that bus. That was a private company. So they have contacted us from our YouTube videos and all, that what kind of project we are doing. So likewise, there are a lot of capability. We met with a person last year in Pragati Maidan, and they were working in a small company. After some time, they have planned to open a small company. They have got the project for counting the crowd inside the Allahabad fair, and they got approx 6 or 7 crore project from the government of India. So other than these company, if you are good with these techniques, you will be able to do lot of things separately. And coming to the career, there are a lot of company, Amazon, Nvidia, Google is keen to have those kind of professionals which are proficient with the deep learning and AI techniques. They're searching because Google is working with the self-driving car testing. Nvidia is very much keen for having deep learning and AI experts. And Amazon, you have heard about they are planning to deliver the packets to the drone. So there are a lot of AI, artificial intelligence, deep learning, and techniques is required for doing such kind of things. So likewise, if we will see the scenario, current scenario, there are different kind of automation is required, and those capability are available in this AI techniques. So once you will be good with these techniques, this is very easy to work with any company in the field of automation. And automation market is going to be big in the coming era. So that's it from my side.